Today I would like to share with you a small concept on active and reactive power transfer between inverter and grid. I am trying to explain to you how actually we send active and reactive current to the grid from the inverter. This is the basic structure of a grid-connected inverter. We have a DC source at the input. Then the inverter bridge, which can be a single-phase or three-phase topology, and it is made using power electronic switches such as MOSFET or IGBT. At the output, we have filter to mitigate the harmonics in the grid current. The filter can be an L filter, or LC filter, or LCL filter. Now I will replace this structure with its equivalent circuit. Here, VINB is the voltage generated by the inverter. VG is the grid voltage and IG is the grid current. And VL is the voltage drop across the filter inductor. By applying KVL across the loop, we will get this equation. That is, inverter voltage is equal to the sum of grid voltage and voltage drop across the inductor. One thing is to note that these are the vector sum, not the arithmetic sum. Now I will explain the concept of active power transfer. For that we need to draw the phasor diagram. First I will draw the grid voltage. Now let me mark the current. Since we are sending active current, the current will align in phase with the voltage. Now we need to mark the voltage drop across the inductor. We know that, in case of an inductor, voltage always leads the current by 90 degree. Therefore we can mark VL at an angle 90 degree from the current. Now add the two phases, VG and VL, to get the inverter voltage. From the phasor diagram, it is clear that inverter voltage leads the grid voltage by a small angle, and the magnitude of the two voltages are almost the same. So we can conclude that, in order to send active current to the grid, the inverter need to generate a voltage, which has to lead the grid voltage by some angle. We can increase or decrease the current by adjusting this angle. In power system, we have learned equation for active power as V1 V2 by X, sine delta. Similarly we can write active power as inverter voltage into grid voltage divided by XL into sine delta. So the active power is proportional to the sine of angle between inverter voltage and grid voltage. Now I will explain about how inverter send reactive current. Again we start with drawing the phasor diagram. First I will draw the grid voltage. Now we need to draw the current. The current can be leading or lagging the voltage depending on whether we are sending or receiving the reactive current. I am considering a lagging current here. Now the inductor voltage drop VL should lead the current by 90 degree. I will mark that also. Now add the two phases VL and VG to get inverter voltage. From phasor diagram, it is clear that the inverter voltage and grid voltage are in phase, and the magnitude of inverter voltage is greater than the grid voltage. So we can conclude that, in order to send a lagging reactive current to the grid, the inverter need to generate a voltage, which should be aligned in phase with the grid voltage, and its magnitude should be higher than the magnitude of grid voltage. Similar to this, we can draw the phasor diagram in case of sending leading reactive current to the grid. In that case the inverter voltage magnitude is lower than the grid voltage, but both are aligned in phase. So the conclusion is that, in order to send a leading reactive current to the grid, the inverter need to generate a voltage, which should align in phase with the grid voltage, and its magnitude should be lower than the grid voltage magnitude. Similar to active power, we know the equation for reactive power as Q is equal to V1 minus V2 into V2 divided by X. So here we can write it as inverter voltage minus grid voltage into grid voltage, all divided by omega L. So the reactive power is proportional to the difference of magnitude of grid voltage and inverter voltage. So I will just conclude what we learned today. To send active current to the grid, magnitude of inverter voltage and grid voltage should be the same, and the inverter voltage should lead the grid voltage by some angle. To send lagging reactive current to the grid, magnitude of inverter voltage should be higher than the grid voltage, and the phase difference between them should be zero. To send leading reactive current to the grid, magnitude of inverter voltage should be lower than the grid voltage, and the phase difference between them should be zero. This is the end of this presentation. Thanks for watching.